Yeah, good morning, students. In the previous classroom discussion topic, we had a discussion on different methods of passing parameters to a function. So we discussed two important methods. One is call by value method, and another one is call by reference, which is also known as call by pointer method. So the call by value method, in which the values of the actual parameters will not be modified even if you modify the formal parameter values. Whereas in call by pointer or reference method, whatever the changes or modifications we will do for the formal parameters, if you want those changes to be reflected to actual parameters also, then the call by pointer or call by reference mechanism is used. That we have seen with a simple example program on swapping of two numbers in both variations we discussed in the previous CDT. Now, the today's classroom discussion topic is on another important category of the functions, which we can call it as recursive functions, that we are going to discuss in today's discussion. Now, I would like to share my screen. So, the today's CDT is on recursion. So, the lecture level outcomes are, upon completion of this lecture, students will be able to develop the code in C using recursive functions concept. So what is a recursion? Any function which calls itself is called a recursive function, and such functions calls are called recursive calls. So function calling by itself is called it as a recursion. Recursion cannot be applied to all problems, but it is more useful for the tasks that can be called in a similar subtasks. So it is the idea of representing problem with smaller problems. Any problem that can be solved recursively can be solved iteratively, but vice versa is not always true. So when recursive function call itself, the memory for called function allocated and different copy of the local variables is created for each function call. So some of the programming problems which can be solved by using recursion or finding of a factorial, finding the nth Fibonacci number, as well as to print the Fibonacci sequence, we can use this. And another one is tower of Hanai's problem you can solve. So like that, there are plenty of problems you may come across in the design and analysis of algorithms also, where you can apply this recursion to solve these particular problems. So how this recursive function works? So if you see that, so this is a skeleton of this function here. So we are defining function func1. So in the main function you are calling fcnc1, then the control will come to this body of this function func1. So it will execute this function, and again within the function func1, again you are calling func1 again. So again it will be called this function. So how this, it is calling the same function func1 itself, you are calling repetitively. So this is what we are calling it as a recursive function call. Fine. So the properties of recursion, if you see that a recursive function can go infinite, like a loop, infinite loop. So to avoid infinite running of recursive function, there are two properties that a recursive function must satisfy. So one is the base case or base condition or base criteria. So it allows the recursion algorithm to stop. A base case is typically a problem that is small enough to solve directly. So for example, if you take a factorial problem, so you are stopping the factorial of n in terms of again n minus 1 factorial. When n value becomes 0, 0 factorial is 1. So where you are stopping the factorial problem definition. Fine. So like that, this condition is called it as a base or terminating condition. And another important property is that progressive approach. So a recursive algorithm must change its state in such a way that it moves forward to the base case. So that means here if you are taking 5 factorial, so 5 factorial can be calculated as in terms of 4 into 5 into 4 factorial. So again 4 factorial you can calculate in the form of 4 into 3 factorial. 3 factorial again you will calculate in the form of 2 in 3 into 2 factorial. Like that it should be moving. The factorial problem will always moves from one state to the other state such that it will moves forward to the terminating condition or base condition. That is what we are calling it as a progressive. So here this is an example problem to find the factorial of a given number using recursion. So recursion is nothing but calling the same function by itself. So within the function you are calling the same function by itself. So that means here in fact function you are calling again a fact function. Fine. So this is what a recursive call. This is what we are calling it as a recursive call. So how we are finding here, enter a number. So we are passing that particular number to the function. So this is the function call statement. So once it calls this function, control will come to this, and then it will check whether this n value is equal to 0, then we are returning 1 because 0 factorial is 1. Else if n is equal to 1, then also we are returning 1. If n is greater than 1, that means if it is greater than 1 means 2, 3, etc., then we are returning n into fact of n minus 1. So that means here we are calling again the same function by n minus 1 value. So like this we are recursively calling that. So when your recursion is stopped, either n is equal to 1 or n equal to 0, your recursive calling will be stopped. Then it will returns that result, and that result will be stored in this particular f variable, and we are printing that f. So this is what a recursive function. So this is another problem here, which is used for displaying of the Fibonacci sequence here. So we are calculating that factorial Fibonacci of nth term. We are calculating that. So if n is equal to 0 or n is equal to 1, return n. So fib of 0 is 0, fib of 1 is 1. Else fib of n minus 1 plus fib of n minus 2, that is the previous successive terms, is nothing but its Fibonacci. So this is a Fibonacci is a recursive function we have written here, and we are calling this recursive function in a loop. So how many terms you want to print in the series, Fibonacci series? I want to print n terms, I equal to 1, I less than or equal to n, I plus plus. Printf percentage d Fibonacci of m. So it is not m, you have to pass it as I. Okay, so Fibonacci of I you are passing here. So first Fibonacci of 1, then it returns 1, Fibonacci of 2, 3, 4, like that. So based on that it will return that. Fine. So got the point? Okay, here it is passing fib of 0, fib of 1, 2, 3, m equal to 0 we have given. So you can pass m also, no problem. So now this is practice problems on recursion. So write a program to find the factorial of a given number using recursion that we had discussed in the current CDT. And this is another important problem, converting decimal number to binary using recursion. And this is evaluating this function, f of x function, using recursion here. So this is a lecture level practice problem. Now you have to solve this problem. So develop a C program to find the nth Fibonacci number using recursion. So further readings is that you can refer this textbook on programming in C by E. Balaguruswamy, chapter number 8 for recursive functions. Right. So thank you one and all.